Welcome to Get Your FRQ On. This question is from 2021. It's question 1, and it is calculator active. In the question stem, we are considering the density of a bacteria population in a circular petri dish at a distance r centimeters from the center of the dish. This density is given by an increasing and differentiable function f, and f of r is measured in milligrams per square centimeters. We are also provided with a table for selected values of r and f of r. In part A of this question, we are asked to estimate f prime of 2.25 and interpret the meaning in context. We can use the values from the table to estimate f prime of 2.25. F prime of 2.25 should be equal to f of 2.5 minus f of 2 all over 2.5 minus 2, which is equal to 10 minus 6 over 0.5, which simplifies to 8. So in the context of the problem, this means that when the bacteria are considered 2.25 centimeters from the center of the petri dish, the density of the bacteria population is growing at a rate of approximately 8 milligrams per square centimeter per centimeter. In part B of this question, we are given that the total mass of the bacteria is given by the integral 2 pi times the integral from 0 to 4 of r times f of r dr, and we are asked to estimate the value of this expression using a right-hand Riemann sum. So the total mass in milligrams of bacteria in the petri dish is given by the following. 2 pi times the integral from 0 to 4 of r times f of r dr, which is going to be 2 pi times this huge group 1 times f of 1 times 1 minus 0 plus 2 times f of 2 times 2 minus 1 plus 2.5 times f of 2.5 times 2.5 minus 2 plus 4 times f of 4 times 4 minus 2.5. And so we get 2 pi times the integral from 0 to 4 of r times f of r dr equals 2 pi times this big group 2 plus 2 times 6 plus 2.5 times 5 plus 4 times 27, which eventually gets us 2 pi times 134.5. You're more than welcome to simplify that even further, but at this stage, it is not necessary to do so. In part C of this question, we are asked if the result we got in part B is an over or underestimate, and to explain our reasoning. So we're given in the question stem that f of r is an increasing function. This allows us to conclude that f prime of r is greater than 0. But that's not the function we integrated. We integrated the function r times f of r, although f prime being greater than 0 will come in handy. So we have to consider the actual function r times f of r. If we differentiate that function, we'll need to use the product rule, and we will get r times f prime of r plus f of r. So the bacteria population f of r cannot be negative. That would not make any sense at all. And none of the r values that we were given were negative, nor would that make any sense at all. So we have r always being positive, f prime of r always being positive, and f of r always being positive. So we can conclude from this that the derivative of the expression or function r times f of r is also greater than 0, which allows us to conclude that r times f of r is increasing, which allows us to conclude that our right-hand Riemann sum would be an overestimate. In part D of this question, we're given a new function g of r which is equal to 2 minus 16 times the cosine of 1.57 square root of r cubed. That's why this is a calculator active question. And then we're asked to find the value of k between 1 and 4 exclusive, such that g of k is the average value of this function g of r on the interval from 1 to 4. So in order to find the value of k, such that g of k is equal to the average value of g of r on the interval from 1 to 4, we actually have to know what the average value of g of r is on the interval from 1 to 4, which we can obtain by calculating the integral 1 over 4 minus 1 times the integral from 1 to 4 of g of r dr. And since this is a calculator active question, we're going to use our calculator. So using our calculator, 1 over 4 minus 1 times the integral from 1 to 4 of g of r dr is 9.875795. Now you may be wondering why the extra precision here. The extra precision here is because we're going to use that number somewhere else, and if we round it too much now, our rounded answer could be a little bit too far off for our final answer to receive any of the points. So now we need to determine when g of k is going to equal this value 9.875795. And because this is a calculator active question, we can use our calculator again. So 2 minus this 16 cosine 1.57 square root of k all cubed will equal 9.875795 when k is equal to 2.497. Notice, because we're using our calculator here, somewhere our calculator is going to round, and we round it here. That's why we want that extra precision in our value of g of k. If you want more AP Calculus AB free response question solutions, like this video, make sure you subscribe to my channel, and you can also find me on X at x.com/getyourfrqon.